Hey there, and welcome to this explainer. Today, we're diving straight into what is, without a doubt, the greatest vanishing act in the history of the cosmos. We're talking about the mystery of the missing antimatter, or as physicists call it, the matter-antimatter asymmetry problem. Just think about that for a second. Literally half of the mathematical equation that makes up our reality is just gone. Well, today we are going to tackle this mind-bending puzzle using a fascinating scientific framework called the triune harmonic dynamics, or THD, hypothesis. This was developed by researcher, inventor, and author Kevin L. Brown, and it genuinely gives us a completely fresh way to look at how everything around us actually came to be. So here's our roadmap for today. We'll kick things off with the missing antimatter mystery, introduce THD by Kevin Brown, break down what's known as the three-step cosmic snap, look into building structural pressure, and finally, we'll hit validation and falsification. All right, let's jump into section 1, the missing antimatter mystery. Seriously, where did half the universe go? I know it sounds like the plot of a late-night sci-fi movie, but this is actually one of the absolute biggest problems in physics right now. When you look up at the night sky, you see a universe packed with billions of galaxies, trillions of stars, planets, and, well, us. But here's the crazy part. Mathematically speaking, none of this should be here. If the universe just followed the basic, simplest rules of physics, space would be completely dark and totally empty. See, our standard models of physics expect a perfect balance. The Big Bang should have pumped out exactly equal amounts of matter and antimatter, a perfect 50-50 split. But there is a huge catch here. Whenever matter and antimatter touch, they completely annihilate each other in this brilliant flash of pure radiation. So if things had stayed perfectly balanced, all the matter and antimatter from the dawn of time would have just wiped each other out. The universe should just be a glowing sea of empty light right now. But obviously, reality tells a different story. Matter completely dominates. Antimatter is pretty much nowhere to be found. Somehow, against literally all mathematical odds, matter won the cosmic lottery. Moving on to section 2, introducing THD by Kevin Brown. To solve a mystery this big, we need a new way of looking at things. So what is THD? Triune harmonic dynamics is a scientific framework authored by researcher, inventor, and author Kevin L. Brown. It gives us this really unique structural lens for understanding complex physics. Instead of just digging through endless math hoping to find one single magic particle that fixes everything, THD looks at how entire systems naturally evolve. It says systems go through 3 stages: emergence, tension, and resolution. Think of it like a rubber band. First, you have the rubber band itself, that's emergence. Then you start stretching it, pulling those ends further and further apart, that's the tension. And eventually you pull it so far that it hits a critical limit and violently snaps. That snap is the resolution. THD takes this exact kind of mechanical logic and applies it to the very dawn of the cosmos. And that brings us to a really foundational truth of the THD model. The universe is a structure, and structures break under pressure. Think of the early universe like the ultimate pressure cooker. When all that matter and antimatter were crammed together, they didn't just casually drift apart. The infant universe was insanely hot, unbelievably dense, and expanding incredibly fast. So the tension inside this cosmic pressure cooker just kept building and building, ultimately forcing the whole system right past its breaking point. That perfect 50-50 balance, it just couldn't hold. The structure fractured. Which brings us to section 3, the 3-step cosmic snap. How did the early universe actually handle all that immense pressure? Well, the THD hypothesis breaks this whole massive event down into a very clear 3-step sequence. Step 1 is the base phase. This is right after the Big Bang, where we have that perfect 50-50 equilibrium of matter and antimatter. Then we hit step 2, the pressure phase. This is where things get violent. The universe is rapidly expanding and cooling down, which causes intense structural stress to accumulate. The perfect symmetry of the universe basically starts to wobble under the strain. And then boom, step 3, the integration phase. The tension hits a fever pitch, and the system literally snaps into a brand new stable state. In that sudden cosmic snap, a permanent slight excess of matter gets locked securely into place. So because of that snap, a small matter excess actually survived the Great Annihilation. When the vast majority of matter and antimatter inevitably collided and canceled each other out, this tiny, locked-in remainder of matter just kept on going. We're talking about maybe 1 extra matter particle for every billion antimatter particles. It is incredibly, almost unimaginably small. But that tiny leftover fraction, that surviving echo of the cosmic snap, is the literal reason our sun, our planet, and you and I exist today. Okay, section 4, building structural pressure. Let's talk about what actually caused this pressure to build up in the first place. There were some very specific, real physical forces acting as the heat in our cosmic pressure cooker. First up is something called CP violation. You can just think of this as a tiny behavioral glitch. It basically means that if you hold up a mirror to a matter particle, its antimatter reflection doesn't behave perfectly the same. It's slightly off. Then you have baryon-number and lepton-number violations. This just means that under extreme, unimaginable heat, the usually strict traffic rules of particle physics start to bend and warp. Add in the intense pressure of space expanding incredibly fast, like the walls of the cooker flying outward, plus a total departure from thermal equilibrium, and you have a system being violently shoved out of balance. All those intense forces eventually push the universe to a mathematical turning point, which we write as PBA is greater than PC. So PBA stands for the combined baryon asymmetry structural pressure. It's basically every single one of those extreme forces we just talked about, all added together into one giant push. And PC? That represents the critical threshold. Imagine a huge concrete dam holding back a rushing river. PBA is the rising, churning water, and PC is the absolute maximum strength of that concrete dam. The THD hypothesis says that the moment the structural pressure, PBA, got bigger than the critical threshold, PC, the dam cracked. The universe couldn't hold its perfect symmetry anymore, and was mathematically forced to shatter into a matter-dominated state. And finally, Section 5, validation and falsification. Because let's be real, a hypothesis isn't hard science unless you can put it to the test. If the THD hypothesis is correct, we actually have very clear ways to test it. This is our scientific scorecard. If we start observing multiple, small asymmetry anomalies clustering together in our data, THD is validated. On the flip side, if a simple, fully symmetric model comes along and perfectly explains everything, THD is totally falsified. Also, if astronomers suddenly discover massive hidden pockets of pure antimatter floating out in deep space, that would prove the hypothesis wrong. But if that PBA index, that structural pressure measurement we just talked about, accurately predicts the precise amount of matter excess we see in the universe today, then the THD model is heavily validated. It gives us real testable boundaries. So, where are the fingerprints? Where do scientists actually point their instruments to measure this stuff? Well, THD tells them exactly where to look. We need to be checking out neutrino experiments, using supercolliders to smash particles and look for heavy decays, doing high-precision searches for electric dipole moments, and listening to the fabric of space-time itself using gravitational wave observatories. This is where the extreme structural pressure of the early universe would have left its permanent mark. To wrap things up, I love how Kevin L. Brown puts it. The universe was never silent. Its rhythm has always been there, waiting to be heard and solved. It is incredibly humbling when you realize that our sheer existence, the literal fact that we are sitting here today, is the direct result of a measurable cosmic harmonic transition, a rhythm that built up under immense, crushing pressure until it finally snapped reality into a matter-dominated focus. Our whole world is just the echo of a cosmic rhythm resolving its tension. So the next time you look up at the night sky, ask yourself, what other unseen pressures are building out there in the dark, just waiting to snap reality into a brand new focus? Thanks so much for exploring the missing half of the universe with me today. See you next time.